Greetings to all, my name is Ntando Sosibo. With me today I have Tando Sekali, Meli Ngwenya, and Andy Ndalosi. Today we'll be showing you our projects, our design projects for our module, which is Earthworks and Pavement Design. And we were given a project brief that we must design for a gravel road and upgrade it into either a 2-lane, a multi-lane, or a 4-lane divided road. But before I go into detail with this project, these are the topics that we're going to be describing to you in this presentation. Number one, we have the design process overview. My friend here will be doing the location and description of the road, and Andile will be doing the reasons for road choice, including problem that requires a solution, and finally, together with all of us, we'll be doing the designs. Thank you. Greetings again. So, for the design process overview, it requires us to upgrade the gravel road to a 2-lane asphalt pavement road. It involves multiple aspects that needs to be carefully designed and planned. These factors can be broadly categorized into technical, environmental, economic, and social considerations. Here's a breakdown of what goes into this process. We have the geometric design. What is the geometric design? It is a plan of the road alignment and profile for safety and efficiency, which includes curves, gradients, and sight distances. Ensures proper lane width with shoulders where necessary. We're designing the cross sections that include the pavement structure, the drainage, and the slopes. Secondly, we have the structural pavement design, also known as the TRH4. Here, we analyze the traffic loads, including heavy vehicles, using the TRH4 guidelines. We design the pavement with layers such as the subgrade, the subbase, the base, and the asphalt surface. We select the appropriate materials for each layer on local conditions. In our location, we had a road that is going to be designed in KwaZulu-Natal. So the local conditions or the climate that we could expect there is under wet regions. Okay. In drainage design, we ensure that the surface water runoff has a proper road slope. We design the side drains, the culverts, and the subsurface drainage to manage water and prevent erosion. Community and safety, where we ensure that the road meets the community needs, and safety features such as the guardrails. Construction planning. This is a phase in construction to minimize disruption and to select appropriate machinery for the terrain. It can be either up, it can be either down. Okay, and finally, but not least, is the regulatory compliance, where we adhere to the local road design standards and regulations for safety and quality.
So in this project, we were given a specification to upgrade the gravel road into a 2-lane premix road. But the location we chose is an unnamed road in Newcastle, Eastbourne. So we, as the engineers, decided to name it Prime Time Road due to our own specifications as per se. So we chose this road because of the growing economic standards. So this is a developing residential area. As you can see, I've posted the picture, which is the houses that have been old houses, but they are now renewing the houses. So people from Johannesburg and now coming back to the rural areas to upgrade their homes. That's why we chose this road to upgrade it to ensure that particularly heavy trucks that are going to be delivering materials to this road can be able to manage all those traffic loadings. And also, the reason to upgrade this road is because of attractions in the area. We all know that in a residential area, they must have a specific attraction to grow the economy of that particular area. So places like dams, a cousin's lifestyle are all those places that are social places that can be able to develop the community into a more economic powerhouse, as per se. Thank you.
Hi everyone, as Mr. Npiso Silva said, I am Mr. M. Dalosa, here to briefly describe reason for road choice, including problem that requires road choice, about as you are designing for an existing road. First, we'd like to look at that the road is used as a primary access to the neighborhood. Yeah, considering that the area is a developing residential area, trucks and heavy vehicles will soon be using the roads. So the best choice we chose for the road is a flexible pavement, because the gravel becomes unusable under rainfall intensity and it becomes dangerous for schools. Schools become inaccessible to teaching and learning become hindering. Well, yeah. Thank you.
So, adding to what Andy Mikalusa just said, so what are we looking at here is the plain view of the area, showing the development houses and showcasing the motivation for the economic growth in this particular area. And taking into consideration, let me show you the geometric design of our road. So you're going to start with the horizontal alignments. Geometry. We have horizontal alignments and vertical alignments. So I'll be looking at the horizontal alignments. So using the data that we have and assume. So for this particular road, we use a design speed of 60 kilometers per hour due to it is a residential area, and so we cannot use maybe 120 kilometers per hour. And for the width of the road, it was 7.5 meters, and the length of the road, it was 3 kilometers. So as we did our calculation for super elevation, we came to an answer of 0.67 times 10 to the exponent 1, which is critical when we're looking at horizontal alignments.
Designing for the vertical alignment. When we're designing for vertical alignment, we consider the design speed, which is 60 kilometers per hour, and we consider the crest vertical curve with an approach of 3.5 and with the exit grade of 2.2, which gives us the gradient of the road of 5.7, which is not bad. Yeah. Plus, we consider the crest curve K, which is 20.738, which gives us the length of 120 meters. Thank you.
So now looking at the structural design of our road, we were able to do a traffic count of the residential road and also make assumptions due to the development of the road that they will be occupied by heavy motor vehicles, commercial vehicles, and also personal vehicles. So taking that into consideration about the terrain for design, we are able to come out with this particular pavement design. This pavement design consists of different layers. Primary layer, the first 3 layers, which is our premix road, the following layers, and then we also have an additional pioneer layer, which indicated that our area is in a wet region. Therefore, we had to add another layer and come out with a pavement design, which which has 4 layers. After doing all those calculations, we came into this cumulative traffic, which is 4,778 times 10 to the power 6 e-acres over a structural design period of 15 years. Also going to the fact that this road is in a residential area. So those calculations were done using the TEL Heritage 4 guidelines. Thank you.
Drainage design is separated into different aspects. We have your side drains, which is the miniature of our culvert design. In side drains, we use it to ensure that the water that comes into the pavement has a direct flow under drainage systems, unlike the culvert design, which is based on a catchment basin system. So when we did calculation, the side drains was to ensure proper collection of runoff during rainfall. And in our calculation, we did a triple Zola channel using Shenji's equation, where we were able to determine the amount of water it can withstand in a day. And the answer we got was 163,9872 times 10 to the power of 6 liters per day. And in culvert design, where we used or we calculated for a box culvert using the South African guidelines for sustainable drainage systems, we were able to determine that the culvert has a depth of 3,6 and under a peak flow of 42,472 meters cubed per second.
So in conclusion, for this project, this road, the upgrade of the gravel road to a 2-lane pavement in Eastbourne, KwaZulu-Natal, was driven by essential engineering calculations to ensure perfect alignment and perfect structural designing. This alignment was optimized to ensure smooth traffic, considering local terrain of the environment and infrastructure and the needs of the community in that area of Eastbourne. The structural design based on TEL 4 standards ensure that the road will be able to withstand the heavy loads that would be affected by the pavement structure for years to come. This project will ensure a safe, durable, and cost-effective road, benefiting the community for the entire lifespan. This was our project for Earthworks and Pavement design. With the aid of my colleagues, we hope that this project should ensure a better upgrade of roads in